Good morning students. Today we are going to talk about the topic Introduction to Polymers. So this is a very important topic concerned to textile technologies because whatever you deal with, it deals with the polymers. You are using fibers and fabrics which is made up of natural as well as synthetic materials which is termed as polymers. So in this class, we are going to discuss the introduction about polymers, the terminologies that is related to polymers. Let us go to the class. Introduction to polymers. So polymers, they are derived from the Greek word poly, which means many, and mer, which means parts. So many parts combine to form polymers. This is a Greek word, and this many parts are simpler units termed as monomers. They are simple units which is termed as monomers, and polymers are macromolecules formed by the combination of these simpler units termed as monomers. Polymers, they make up many living matter. In living organisms, it forms proteins, cellulose, and nucleic acids. Moreover, they also form minerals such as concrete, glass, paper, plastics, rubbers, etc. All these are polymers, both minerals in living organisms. Most of the things that is around you that you are using in day-to-day life, it is a polymer. It is a polymer. If you see the application, it is applied in many industrial areas such as automobiles, defense, electrical and electronic goods, all that you are using here. Computer components, even all these are made up of polymers. So polymers, they were formed from the Greek word poly, which means many parts, and it is made by a simpler unit termed as monomers, and these are the simpler units. Polymers are generally macromolecules or large molecules having high molecular weight, and they are found in living organisms, minerals, etc., where we use in application day-to-day life. Can you name one simple polymer? One simple polymer is polyethylene, which you are using in polythene bags, even papers and everything. And we have polyvinyl chloride, PVC pipes that you are using. So these are some of the polymers, simple polymers that we are using in day-to-day life that you know. And then monomers of nature. Let us take examples. Before taking the examples, let us see what is a monomer. So monomers, they are small molecules, as I have already told you, and they form the basis of larger molecules by forming chemical bonds. They form chemical bonds to produce a large molecule. If you see the example of ethylene, CH2, double bond CH2. This is ethylene. So N molecules of ethylene, on addition polymerization, what is formed is polyethylene. You can see the double bond here, it is converted to a single bond, polyethylene. So double bond is converted to a single bond. So this is called as the monomer, which is a small molecule, and this is the polymer which is a larger molecule, and this is formed via the transfer of electrons. So this is an example of a monomer, and these units are joined. If you see, they are joined in repetition. The same unit repeat again and again in the polymer chain in the case of addition polymerization. So this is joined in repetition, which is one of the important characteristics. It is not necessary that there should be repetition. If two different monomers are there, the monomers will combine and this will be different. So but there repetition will be there of the monomer. Combined monomer repetition will be there. And if you see, the essential feature of this monomer is it is polyfunctionality. You can see that the presence of a double bond, conjugate double bond, which is very much essential. Otherwise, presence of one or more functional groups is necessary. It is necessary for a monomer to form a polymer. Okay. Now, the scientist named Hermann Staudinger. So this scientist, he discovered that monomer make up polymers. He is the one important person who discovered that monomers will combine to form a polymer, and they are artificially constructed into a polymer. So this whole process where monomer is converted to polymer is called as polymerization. This process we label it as polymerization, and there are several monomers. This monomer may be natural or synthetic. Natural monomers may be there, synthetic monomers may be there. Natural monomers in the world, they are among the monomers in natural world are simple sugars, fatty acids, nucleotides, amino acids, etc., and food in the form of carbohydrates, proteins, even fats. All these are natural monomers. One important example is methylene forming ethylene. So this is used in ripening of fruit. So this is one important naturally occurring gas. This is actually a gas which is used in the ripening of the fruit. Coming to the synthetic monomers, a common man-made monomer is vinyl chloride, which we talked here as PVC pipes. Vinyl chloride is a common man-made monomer, and it is used in PVC pipe synthesis. Other examples are ethylene, styrene, bakelite, which is a phenol formaldehyde resin. Okay. So this is about the introduction of the polymers. So far what we have seen, polymers is derived from the Greek word poly, many means parts. Poly means many, mer means part, and the monomer is nothing but they are simple units which make up the large molecules. And in the living organisms, you can see natural as well as synthetic. Natural monomers are simple sugars, fatty acids, nucleotides, carbohydrate, amino acid, protein, fat, as well as methylene, which forms ethylene, which is used in the ripening of the fruit. And synthetic monomer is vinyl chloride is one common example. You can also have polyethylene as the synthetic monomer, bakelite which you use in cooker handles, etc. And in day-to-day life, you can see several polymers in industrial areas, automobiles, defense, electrical, electronic goods, computer components, you use polymers. In all these cases, you use polymers. We gave one example of ethylene converted to the polymer, and what are the characteristics of the monomer? They are joined in repetition in a polymer. They have polyfunctionality, and they have the process where a monomer is converted to polymer is called as polymerization. So this is about a polymer. Now let us see what is the role of a functional group. You have a functional group, the group that is responsible for characteristic reactions in a particular compound. I told you a monomer needs polyfunctionality. So the reactions in a particular compound depends on the number of the functional group that is present. Let us take an examples. What are the examples of functional groups? If you see the examples of functional groups, NH2. So let us see the examples of functional group NHH. This is nothing but amine. This is a functional group, and you can, acid functional group. C double bond OH. This is a functional group which is an acid, and you can have OH. This is nothing but alcohol functional group. So there are several functional groups that is available. So all these functional groups may be a single or multiple functional groups may be present in a monomer, which may take place in the polymerization process. So the functionality of a functional group is very important. Now coming to the reaction of polymerization. Polymerization is a chemical process where monomers join to form polymer. Often it takes a single polymer will be formed as the product, and you may take a single monomer or a multiple monomer. We already saw example 1, which is the conversion of ethylene to polyethylene. So this let us take as example 1, where you can have a single monomer having a polymer. Secondly, you can have a multiple monomer. Formation of nylon 6,6 is an example. If you see, nylon 6,6 is formed between formation of nylon 6,6, hexamethylene diamine and adipic acid. So N molecules of, I am writing the compound like this, C double bond O, it has an acidic functional group, CH2 4 times. So this is adipic acid, C double bond O, OH. Adipic acid and hexamethylene diamine. So I am having diamine, 2 amino groups. How many methylene groups? Hexa, CH2 6 times. Hexamethylene diamine and adipic acid. So this is adipic acid and this is hexamethylene diamine. So what happens here? There is removal of one of the hydrogen atom. I am writing this as NH. Okay, one hydrogen atom will be removed. The product formed will be, the OH here will be removed, one of the hydrogen will be removed. So the product of nylon will be C double bond O. You can write the rest of the product like this, CH2 4 times C double bond O. You can see that N molecules of water is removed here, plus H, N, CH2 6 times NH, N times. So this is nylon 6,6. You can see in this process, you take 2 different monomer, adipic acid and hexamethylene diamine, where a single polymer of nylon 6,6 is formed. But in the previous example, you take only one monomer where there is polymer formation. So this is about the process of polymerization. In the second part, we saw what is the functional group in a polymer. They are the main groups that is responsible for reactions in a compound, and some functional groups we saw here. I gave you only 3 examples, and these functional groups are responsible for the process of polymerization. And polymerization is the process where monomers join to form a polymer, and we saw 2 examples: conversion of ethylene to polyethylene and formation of nylon 6,6. Okay, so this is about, we have seen 2 or 3 terminologies that is related to polymerization. So it is very important that you go to this terminologies. Thank you. In the next class, we will discuss what is the functionality of a polymer, what is degree of polymerization, the problems related to degree of polymerization, what are the types of that is polymers that is formed, and also the classification of polymers. Thank you.